Hi, I'll go over how to do experiment 7 of ECE286, which is regarding passive filters. So experiment 1 is regarding series passive filters with the RC circuit. So you're inputting a 5-volt source and you have a 1K resistor with in series with a 10 nanofarad capacitor. So let me switch to my diagram. Okay, not diagram, my circuit. So here's my component. So I used a 3K resistor and then my 100 nanofarad capacitor, and I'm just gonna wire my circuit pretty quickly. So my ground, channel 1 is gonna measure the voltage drop across that resistor. Channel 2 is gonna measure the voltage drop across the capacitor. And then let me connect my input voltage. Perfect. Okay, everything is connected. Just make sure this is plugged in. Okay, cool, yo. So now I will switch over to Scopy Connect. Give it a moment. Okay, so signal generator, a 5-volt source at 2 different frequencies, which will be 100 and 10K. So I'll just switch it to 100 and then go and click supply. Okay, beautiful. And go over here and then go and click single and see what happens. Okay, our range is too small, or the time base, so I'm going to increase that and see how, if I can get more results. Yeah, let me just decrease that tiny bit. Okay, cool. Yeah, I got a results for 100 hertz. And then now you can just measure the maximum voltage. Easily just click the button to the left of measure, and you can see what the voltage drops are respectively. And that's how we do experiment 1. You'll have to switch the frequency for the second part, which is to measure a 10K, but then that's it. And then for experiment 2, you're varying the impedance essentially. So you're decreasing the resistance, I believe. Yeah, so you're adding 200 ohm resistors, which causes the resistance to go down because you have 200 ohms in parallel with 1K, which effectively reduces the resistance to less than 200 ohms. So you're decreasing the resistance, and then on this circuit, you're increasing the capacitance. So I'll do one of these. I'll add another capacitor in parallel with the previous capacitor. So let me just move over a cable. And so, yeah, cool. And that is not showing anymore. Cool. So there's my second capacitor. And again, I'm using a 3K resistor, so these results will not match, which you will get. So then now I'm just gonna measure the same thing as before. And then, wait, pardon me. You're measuring the cutoff frequency. Sorry for this section. You're measuring the cutoff frequency. So you'll do the base circuit, which is the same circuit as experiment 1, measure the cutoff frequency, do it again for this circuit over here, and then the one on the right. So I'm doing the one on the right. You can obviously manually change the frequency until you measure it. That's a viable option, but time consuming. So I would suggest going to the network analyzer and then make sure channel 1 or channel 2, either one, is connected in parallel with your voltage source. So that way it has a reference voltage. So I'm going to make it my channel 1. So now channel 1 is in parallel with my voltage source, and channel 2 is measuring the voltage drop across the capacitors. So let's see if this is still 5 volts. Yeah, it's 5 volts. But it's peak to peak, I believe. So let me go and click single. So give it a quick moment to compile all the data points it needs to. Okay, cool. So now it's done compiling all those data points. So now what I'm going to do is I'm going to click the gear icon on the top right and then do a quick snapshot. And then now it saves that so that way I can do another recording because I want to overlap those two different frequency sweeps that I will be measuring. So I only measure the frequency sweep across those resistors. Now I need to measure the frequency sweep of the resistor. So I'm going to switch my channel to wires and put it across that resistor. So previously I had it in this orientation, like this, and that's how I just got the data. Oops, there we go. So that's how I had it. But now I'm going to switch it so it's like this. So it's measuring the voltage drop across that resistor. And then I'm going to click single and give it a moment. But I don't necessarily need to give it a moment because I already see that little cutoff frequency right there. So I'm just going to skedaddle this point to the left. And so now this one is tied to F1. So if you look over here, you see how if I move this F1 is like changing drastically. So yeah, I'll just switch it to right around there. So now that cutoff frequency for a circuit with a equivalent circuit of a 3K resistor in series with 200 nanofarad would be about 220 hertz. And then, of course, you have to do the same for both of these circuits. So I only did one. You have to do it for the other one along with that base circuit or the circuit from experiment 1. And that's, there's also one bonus section. You can't necessarily do this with the M2K, but if you're in the lab, you possibly could. But ask your TA about this section. But that's how you do lab 7 of ECE 285, 286. My bad. Good luck.